then we are ready to show you the results from today. First, I would like to show you the PTA biplot from the data that you generated in the factory. As you can see, it's a bit different from what we expected. We can here. Okay. Yes, we can see that the underdeveloped defect is closest to the reference, and the scores is very opposite the underdeveloped and the reference. And the scores is also the one that are highest in exceedity and that are lowest in Randstad. Whereas the underdeveloped and the reference is close to the ascendancy and burned. Here you should notice that the PC1 is explained by 92.6%, whereas the PC2 is only explained by 6.7%. So the biggest difference is seen from this side to the other.
Yeah, and this is actually the opposite of what I expected, and also the opposite of the findings in TINAS. So the burned descriptor was close to the reference and the underdeveloped. So I don't know exactly how to interpret this in terms of the reference, because it's clearly the opposite. So we need some more time to think about that. But the most important thing here is to notice that the big question here was, will we create something else than just noise? And the good news is, so the big question here was, will this methodology work at all when you try to execute in 15 minutes? That would normally take at least 2 days when you do a sensory profiling. So the fact that we get 92% of the variance explained by PC1 seems like it's a pretty, the methodology works in this setting. But then again, I've also heard some clever person saying that the smaller number of replicates you have, the easier it is to get a big explanation. Do you have a comment on that, Venda?
Maybe, is this the average over the 3 curves?
Yes. Yeah, it's the average data that you can see up here.
Because you have average, then you get that the first component, because you have, it's on. Because you have taken the average, then of course the first component here will be, can be big. But I think actually it's quite surprisingly to see that this 92% in one component, and effectively the second component is nothing. Yeah. Because that's just noise, because there's so much noise in this data anyway, even though you have taken the average. So it's just basically saying something about you have the underdeveloped reference on the one side, and then you have the scorched on the other side, and that seems to be really something with, you have something like an acidic versus something like burn transit dimension. But throughout today, also with the last cupping, if I may make a comment, I think I'm really amazed to see the way people can taste all these things. And I can also sort of observe from a personal point of view that I think on the vocabulary, people have very individual views on how the coffee should taste, and then also how they use descriptors to express what they think it should taste. And so I think this, when I look at that you say it's a bit difficult to explain in terms of the terms, I think we have a lot of individual views here in this audience. And the thing is, when I look, for instance, at the tasting just we've done now, I mean, in some of the coffees you can very clearly notice the grassy green notes, which were oxidized notes from fats. If you know these kind of things, and you know the chemicals, I will predict it will be hexanol, will be trans-2 hexenol in these things. And that I think is something one should be aware of, that also with some of the tar and tobacco and the smoke kind of flavors that were in the last cupping, very clearly flavor notes. And I think it could be maybe useful in terms of the use of vocabularies to work towards some kind of simple kids standards that could be sort of circulated among the small producers. I know there's systems available also in the brewing industry and things like that, and they are very expensive, and but I think there can be, it should be easy, and maybe we should discuss that to make just some simple sets of maybe 10 to 20 flavors for orders that people can actually use down in their roaster just to say, okay, well, this is actually what we mean when we're talking about smoke, and this is what we mean when we have, because I think that is improve, I think, maybe also the communication between the roasters, because then they know, oh, okay, that's what you mean. Because I think to me this is a very, I'm very interested in what I see, but I think there's some communication and in different levels here.
Yeah, we've got the Nest du Café, but perhaps we could design a more, even more scientific kit that
it doesn't have to be scientific.
No, but I mean
it is useful.
Yeah.
And I mean, you can. There's so many of these descriptors. You can make something that resembles that in a simple way. And you can just have a little strip, and then you can. It's like going through the airport, through the perfumery department. You can just sniff a little bit. Say, oh, okay, that's the one that we are after. Then you can find it in your coffee. Another observation that I made is that this cooking is going very fast, and I'm really amazed at that. I see it in the wine, people tasting wine also, they can do it really fast. And I think in some way, you guys, you're really super tasters in a way. I'm really amazed, and you have a very rapid brain because you have tasted so much. But I also noticed that if you really would do this in a sensory lab, is that you have adaptation effects, and the olfactory system is really you get adaptation, both on taste and on olfaction. And within 2 or 3 tastings, you are actually tasting a quite different coffee, not due to the fact that the coffee is different, but just because you have a sensory adaptation. And you build this up throughout these cookings. And so some of the unclarities could also be maybe related to that you actually are not going all the time back to baseline with your senses. And this is an issue I'm not sure if this is a systematic error when people do these cuppings, or if they have somehow adapted to cope with this, but I put it really forward as a question, and one has to be aware of that, because really adaptation is happening. We have so much evidence from other studies that olfactory adaptation happens quite quickly, and it sometimes can take 2 or 3 minutes to really come back to baseline. So that's something one has to consider as well.
Yeah, that would be really interesting to do some analysis of this. Palate fatigue, I think, is another way that it's talked about in the coffee business. So, okay, great. But also, please remember that the whole descriptor definition that we did yesterday with a small group is really, really important, because all the statistics depend on these descriptors. So, and we only had 15 to 20 minutes or something like that. So perhaps the training of the panel, which is a really important aspect of a sensory profiling, could have given us better data. I don't know. Yeah, that was just a few words about that.
Yes, then I'll show the profile plot that I also showed you earlier. And as you can see, you were a bit afraid of using the scale. You were rating it from 2 to 6 in almost all the attributes. The black line that you can see are the error rates, and again the frame is telling us whether it's significant. So you found 5 significant attributes out of these 7. So this means that, what is it? Can you read it? It's the malt and the dark, this is the dark berries and this is malt. It doesn't seem to influence, the defect doesn't seem to influence these attributes, but acidity and burnt does. If we look closer at the burnt, we can here see, that was also what we saw in the PCA plot, but that the reference and the underdeveloped are the samples that you rated highest in burnt. And you found a significantly difference. But you can also see from all these lines, you are listed here as assessors, you can see that you differ a lot. So maybe more training would make it more straight. The goal is to be as close to the, as close group together as possible. And then after this, we tested, we looked into whether the cleansing of your palate, it worked. And here we see the Toggle 1 plots, where with the group that used palate cleanses, and here we can see that you only found 2 significantly differences. You can see here that you are closely grouped together, whereas this one is spread much more around. And this is quite surprising when we look at this one where you actually used the palate cleansers. Sorry, you didn't use palate cleansers. you found much more significant differences, and it seems that you are agreeing more, a little more. It's still spread around, but it seems that there is a little difference here. So that's quite interesting that, yeah, you as couples, maybe it's because you're not used to use palate cleansers that it works best for you not to do it, or, yeah.
Yeah, so it's a surprising conclusion because normally you are advised to clean your palate in sensory profiling sessions, but here the group with no palate cleansers made better data than the group with who did use palate cleansers. So that's pretty interesting. I think that's an interesting question in itself. Should we use palate cleansers or not? And this is a pretty conclusive. But the conclusion, the why of this is not clear because it could be confusion of using palate cleansers when you're not used to it. It could give better data. So the question is if we could find the perfect palate cleanser so that you could be trained in using it and then create better data than if you didn't use it. But the data here seems that the group using palate cleansers created worse data than the group who didn't use it.
But
okay?
Still, we have to say that it's not a scientifically tested study. We have to do much more research to come up with any conclusion. Here it's just like fun fact to show you. So the last thing is that if you want to look in how each processor performed, this is just to show you what you can get out of the program. Here we have assessor 1. The red dotted lines show the panel average in when you are rating the baked attribute, and each of the dots is the 3 replicates that you were tasting. So the best thing is if these 3 dots are very close to each other, that would mean that you were really good in replicating yourself. So this assessor did a very good replication in these 2 samples. This one was a bit further away, but not as far away as this one. So this assessor, you can say that he was quite good, but on the other hand, he also just, as most of the attributes, he rated the same. So there's also a better chance to be good when you're doing it like this.
Yeah, he didn't really use the scale, so it's easy to replicate yourself if you just choose the same number all the time.
Then yeah. And here you can see a guy that used the scale much more. He is down to 2 here and up to 6. But here he is not so good in replicating himself, but up here he is a bit better. But he is still very far from the panel average. So that's also some kind of data that you can get out of the program.
Yeah, and then so you can analyze the different types of descriptors. Some people might be good at some descriptors to replicate themselves and bad at other descriptors. And so it's a nice thing to have feedback. Which descriptors are you good at and which aren't you good at? Because then you can train in the blind spots.
Yeah, and you can see that this guy really needs some more training in the burned and what's it, stringency. Or at least we need to make the panel agree more in these attributes. And of course you didn't have any or only a very little training today, so maybe much